Officially hello and welcome everyone. Thank you for joining today's DCCAP's virtual series, QA Masterclass. This is where we invite software experts to share their insights, and this is the 8th edition of the Masterclass, and it's a great one to end the year. Today we'll be talking more about the screenplay pattern, a design pattern for automating interactions better. My name's Catherine. I'm the partner manager here at DCCAP. As some of you may know, DCCAP is the parent company of QA Touch, which is our test management software solution this series is based on. We also have several additional products and solutions in e-commerce with our seamless integration with Chloris, as well as product information managed with FlexiPIM and in-depth data analytics with Visby. And please feel free to visit dccap.com for more information about any of our products or services. Also at qatouch.com/QA-masterclass. And feel free also to use the hashtag QA Masterclass to keep the conversations going online. During the upcoming presentation, whenever you have any questions, you can add them in the Q&A tab, comment in the chat whenever you have them, and we'll be sure to keep an eye out on those and make sure we get to them all by the end. So without further ado, I'm going to go ahead and bring on our speaker, Andrew Knight. Andrew is the Automation Panda, an engineer consultant and international speaker who builds solutions for software testing problems. He has designed and built robust test automation projects for operating systems, service APIs, and web apps with thousands of tests running continuously. He's the lead developer for Boa Constrictor, the .NET Screenplay Pattern. He also mentors people in good development testing and BDD practices. And he currently works full-time as a lead software engineer in test at PrecisionLender, a Q2 company. He's a technical blogger and writes on automationpanda.com. Thank you so much for joining us, Andrew. And I'll let you go ahead and take over from here.
Great, thanks for having me. Let me share my screen. Well, hello everyone. Welcome to this masterclass. Personally, I'd like to thank QA Touch for inviting me to speak. Today, I'm going to introduce you all to the screenplay pattern, which can help you make better interactions for better automation. As Catherine introduced me, my name is Andrew Knight, but you can call me Pandy for short. I'm the lead software engineer and test at PrecisionLender, a Q2 company. As a software engineer and test, I build solutions to testing problems. For example, I lead the development of PrecisionLender's end-to-end test automation solution that currently runs thousands of tests daily. I've helped dev teams shift left with BDD practices like Three Amigos and example mapping. And I'm also the lead developer of Boa Constrictor, which we will see today in our session. Outside of my day job, I write and speak frequently as the Automation Panda. So be sure to read my blog and follow me on Twitter at Automation Panda. Let's start by defining that big I word I tossed around earlier. Interactions. Simply put, interactions are how users operate software. For this talk, I'll focus on web UI interactions, like clicking buttons and scraping text. Interactions are indispensable to testing. The simplest way to define testing is interaction plus verification. That's it. You do something and you make sure it works. Think about any functional test case that you have ever written or executed. The test case was a step-by-step procedure in which each step had interactions and verifications. Here's a simple example of a DuckDuckGo search test. DuckDuckGo is a search engine just like Google or Yahoo. The steps here are fairly straightforward. Opening the search engine requires navigation. Searching for a phrase requires entering keystrokes and clicking the search button. Verifying results requires scraping the page title and result links from the new page. Interactions are everywhere. Unfortunately, our industry struggles to handle automated web UI interactions well. Even though most teams use Selenium WebDriver in their test automation code, every team seems to use it differently. There's lots of duplicate code and flakiness too. Let's take a look at the way many teams evolve their WebDriver-based interactions. I will use C# for code examples, and I will continue to use DuckDuckGo for testing. When teams first start writing test automation code using Selenium WebDriver, they frequently write raw calls. Anyone familiar with the WebDriver API should recognize these calls. The WebDriver object is initialized using, let's say, Chrome driver for the Chrome browser. The first step is to open the search engine by calling driver.navigate.goToURL with the DuckDuckGo website address. The second step performs the search by fetching web elements using driver.findElement with locators like these. And then you can call methods like sendKeys and click. The third step uses assertions to verify the contents of the page title and the existence of result links. Here, I'm using a C# library called Fluent Assertions, which you can say should be greater than 0. Finally, at the end of the test, the WebDriver quits the browser for cleanup. Otherwise, you might have zombie processes. Like I said, these are all common WebDriver calls. Unfortunately, there is a big problem in this code. Race conditions. There are 3 race conditions in this code segment in which the automation does not wait for the page to be ready before making interactions. WebDriver itself does not automatically wait for elements to load or for titles to appear. Waiting is a huge challenge for web UI automation, and it's one of the main reasons for what we call quote-unquote flaky tests. You could set an implicit wait that makes calls wait until target elements appear, but they don't work for all cases, such as the title in race condition number 2. Explicit waits provide much more control over waiting and timeouts. They use a WebDriver wait object with a preset timeout value, and they must be placed explicitly throughout the code. Here, they're placed in the 3 spots where race conditions could happen. Each wait.until call takes in a function and returns true when that condition is satisfied. These waits are necessary, but they cause new problems. First, they cause duplicate code because web element locators are used multiple times. Notice how search form input homepage is called twice here. Second, raw calls with explicit waits make code less intuitive. If I remove the comments from each paragraph of code, what's left is basically a wall of text. It's difficult to understand what this code does at a glance. To remedy these problems, most teams use the page object pattern. In the page object pattern, each page is modeled as a class with locator variables and interaction methods. So, a search page class could look like this. At the top, there could be constants for the page URL and variables for the search input and search button locators. Notice how each has an intuitive name. Next, there could be a variable to hold the WebDriver reference. This reference would come via dependency injection through the constructor. The first method would be a load method that navigates the browser to the page's URL. And the second method would be a search method that waits for the element to appear, enters the phrase into the input field, and clicks the search button. This page object class has a decent structure and a mild separation of concerns. Locators and interactions have meaningful names. Page objects require fewer lines of code than raw calls at first, or they may require a few more lines than raw calls at first, but their parts can easily be reused. The original test steps can be rewritten using this new search page class. Notice how much cleaner this new code looks. The other steps can be rewritten using page objects as well. Unfortunately, page objects themselves suffer problems with duplication in their interaction methods. Suppose a page object needs a method to click an element. We already know the logic. Wait for the element to exist and then click it. But what about clicking another element? This method is essentially hard-coded for one button here. A second click method is needed to enter on the other button. Unfortunately, the code for both methods is the same. The code would be the same for any other click method too. This is copy pasta, and it happens all the time in page objects. I've seen page objects grow to be thousands of lines long due to duplicative methods like this. At some point, some teams will say, aha, more duplicate code? We can solve this problem with more object-oriented programming. And look, create the infamous base page, a parent class for all other page object classes. The base page will have variables for the WebDriver and the wait objects. And it will also provide common interaction methods, such as this click method that can click on any element. Abstraction for the win. Child pages will inherit everything from the base page. Child page interaction methods frequently just called base class methods. I've seen many teams stop here and say, you know, this is good enough. Unfortunately, this isn't very good at all. The base page helps mitigate duplicate code, but it doesn't solve its root cause. Page objects inherently combine two separate concerns, page structure and interactions. Interactions are often generic enough to be used on any web element. Coupling interaction code with specific locators or pages forces testers to add new page object methods for every type of interaction needed for an element. Every element could potentially need a click, a text, an is displayed, or any other type of WebDriver interaction. There's lots of extra code that shouldn't be necessary. The base page also becomes very top-heavy as testers add more and more code to share. Most frustratingly, the page object code I showed here is merely one type of implementation. What do your page objects look like? I'd bet dollars to donuts that they look different than mine. Page objects are completely freeform. Every team implements them differently. There's no official version of the page object pattern. There's no conformity in its design. Even worse, within its design, there's almost no way for the pattern to enforce good practices. That's why people end up arguing whether page object locators should be public or private. Such a frivolous argument. Page objects would be better described as a convention than as a true design pattern. There must be a better way to handle interactions. Thankfully, there is. Let's take a closer look at how interactions happen. First, there is someone or something who initiates the interactions. Usually, this is a user. They're the ones making the clicks and taking the scrapes. Let's call them the actor. Second, there's the thing under test. For our examples in this talk, that would be a web app. It has pages with elements. Web page structure is modeled using locators to access page elements from the DOM. Keep in mind, even though we're talking about a web app here, the thing under test could also be anything else, like a mobile app, microservice, or even a command line. Third, there are the interactions themselves. For web apps, they could be simple clicks and keystrokes, or they could be more complex interactions, like logging into the app or searching for a phrase. Each interaction will do the same type of operation on whatever target page or element it is given. Finally, there are objects that enable actors to perform certain types of interactions. For example, browser interactions need a tool like Selenium WebDriver to make clicks and scrapes. Let's call these abilities. Actors, abilities, and interactions are each different types of concerns. We could summarize their relationship in one line. Actors use abilities to perform interactions. Actors use abilities to perform interactions. This is the heart of the screenplay pattern. In the page object convention, page objects become messy because concerns are all combined. The screenplay pattern separates concerns for maximal reusability and scalability. So let's learn how to screenplay using Boa Constrictor. Boa Constrictor is an open source C# implementation of the screenplay pattern that my team and I developed at PrecisionLender. Like I said before, it is the cornerstone of the PrecisionLender's end-to-end test automation solution. It can be used with any .NET test framework like SpecFlow or NUnit. The GitHub repository name is q2ebanking/Boa Constrictor, and the NuGet package name is boa.constrictor. Currently, it's at version 0.6.1. Let's rewrite that DuckDuckGo search test from before using Boa Constrictor. As you watch this talk, I recommend just reading along with the code as it appears on the screen to get the concepts. Trying to code along in real time might be challenging. After this talk, you can take the official Boa Constrictor tutorial to get hands-on with the code. To use Boa Constrictor, you will need to install the Boa Constrictor and Selenium WebDriver NuGet packages. My example code will also use Fluent Assertions and Chrome Driver. The actor is the entity that initiates interactions. All screenplay calls start with an actor. Most test cases need only one actor. The actor class optionally takes 2 arguments. The first argument is a name, which can help describe who the actor is. And the name will also appear in the messages that are logged. The second argument is a logger, which will send log messages from screenplay calls to a target destination. Loggers must implement Boa Constrictor's iLogger interface. And here, the console logger is a class that will log messages to the system console. You can define your own custom loggers by implementing iLogger. Abilities enable actors to initiate interactions. For example, an actor needs a Selenium WebDriver instance to click elements on a web page. Read this new line in plain English. The actor can browse the web with a new Chrome driver. Boa Constrictor's Fluent-like syntax makes its call chains very readable. Actor.can adds an ability to an actor. Browse the web is an ability that enables actors to perform web UI interactions. Browse the web.with provides the WebDriver object that the actor will use, which in this case is a new Chrome driver object. Boa Constrictor supports all browser types. All abilities must implement the iAbility interface. Actors can be given any number of abilities. Browse the web simply holds a reference to the WebDriver object. Web UI interactions will retrieve this WebDriver object from the actor. Before the actor can call any WebDriver-based interactions, the web pages under test need models. These models should be static classes that include locators for elements on the page and possibly page URLs or resource paths. Page classes should only model structure. They should not include any interaction logic. That was the problem with the page object convention. The screenplay pattern separates concerns of page structure from interactions. That way, interactions can target any element, maximizing code reusability. Interactions like clicks and scrapes work the same regardless of the target elements. The search page class has two members. The first member is a URL string named URL. The second member is a locator for the search input element named search input. A locator has two parts. First, it has a plain language description that will be used for logging. Second, it has a query that is used to find the element on the page. Boa Constrictor uses Selenium WebDrivers by queries. For convenience, locators can be constructed using the statically imported L method. The screenplay pattern has two types of interactions. The first type of interaction is called a task. A task performs actions without returning a value. Examples of tasks include clicking an element, refreshing the browser, and loading a page. These interactions all do something rather than get something. Boa Constrictor provides a task named navigate for loading a web page using a target URL. Read this line in plain English. The actor attempts to navigate to the URL for the search page. Again, Boa Constrictor's fluent-like syntax is very readable. Clearly, this line will load the DuckDuckGo search page. Actor.attempts_to calls a task. All tasks must implement the iTask interface. When the actor calls attempts to on a task, it calls the task's perform as method. Navigate is the name of the task, and .toURL provides the target URL. The navigate task's perform as method fetches the WebDriver object from the actor's ability and uses it to load the given URL. SearchPage.url comes from the search page class we previously wrote. Putting the URL in the page class makes it universally available. The second type of interaction is called a question. A question returns an answer after performing actions. Examples of questions include getting an element's text, location, and appearance. Each of these interactions returns some sort of value. Boa Constrictor provides a question named a value attribute that gets the value of the text currently inside an input field. Read this line in plain English. The actor asking for the value attribute of the search page's search input element should be empty. Actor.AskingFor calls a question. All questions must implement the iQuestion interface. When the actor calls asking for, or the equivalent asks for method, it calls the question's request as method. Value attribute is the name of the question, and .of provides the target web element's locator. The value attribute's request as method fetches the WebDriver object for the target element to exist on the, fetches the WebDriver object, waits for the target element to exist on the page, and scrapes its return value attribute. SearchPage.searchInput is the locator for the search input field. It comes from the search class, or search page class. Finally, once the value is obtained, the test must make an assertion on it. Should be empty is a fluent assertion that verifies that the search input field is empty when the page is first loaded. The test case's next step is to enter a search phrase. Doing this requires two interactions: typing the phrase into the search input and clicking the search button. However, since searching is such a common operation, we can create a custom interaction for search by composing the lower level interactions together. The search DuckDuckGo task takes in a search phrase. Its perform as method calls two other interactions, send keys and click. Using one task to combine these lower level interactions makes the test code more readable and understandable. It also improves automation reusability. Read this line in plain English now. The actor attempts to search DuckDuckGo for Panda. That's concise and intuitive. The last test case step should verify that the result links appear after entering a search phrase. Unfortunately, this step has a race condition. The results page takes a few seconds to display result links. Automation must wait for those links to appear. Checking too early will make the test case fail. Boa Constrictor makes waiting easy. Read this line in plain English. The actor attempts to wait until the appearance of result page links is equal to true. In simpler terms, wait until the result links appear. Wait is a special task. It will repeatedly call a question until the answer meets a given condition. For this step, the question is the appearance of result links on the result page. Before links are loaded, this question will return false. Once links appear, it will return true. The condition for waiting is for the answer value to become true. Boa Constrictor provides several conditions out of the box, such as equality, mathematical comparisons, and string matching. You can also implement custom conditions by implementing the iCondition interface. Waiting is smart. It will repeatedly ask the question until the answer is met, and then it will move on. This makes waiting much more efficient than hard sleeps. If the answer does not meet the condition within the timeout, then it will raise an exception. The timeout defaults to 30 seconds, but it can be overridden. Many of Boa Constrictor's WebDriver-based interactions already handle waiting. Anything that uses a target element, such as click, send keys, or text, will wait for the element to exist before attempting the operation. We saw this in some of the previous example code. However, there are times where explicit waits are needed. Interactions that query appearance, existence, or count do not automatically wait. The final step is to quit the browser. Boa Constrictor's quit WebDriver task does this. If you don't quit the browser, then it will remain open and turn into a zombie. Always quit the browser. Furthermore, in whatever test framework you use, put the step to quit the browser in a cleanup or teardown routine so that it is called even when the test fails. And there we have our completed test using Boa Constrictor's screenplay pattern. All the separated concerns come together beautifully to handle interactions in a much better way. As we said before, the screenplay pattern can be summed up in one line. Actors use abilities to perform interactions. It's that simple. Actors use abilities to perform interactions. For those who liked object-oriented programming, the screenplay pattern, in a sense, is a solid refactoring of the page object convention. Solid refers to 5 design principles for maintainability and extensibility. I won't go into detail about each principle here because the information is a bit dense. But if you're interested, then snap a quick screenshot and check out each of these principles later. Wikipedia is a good source. You'll find that the screenplay pattern follows each one nicely. So, why should you use the screenplay pattern over the page object convention or raw WebDriver calls? There are a few key reasons. First, the screenplay pattern, and specifically the Boa Constrictor project, provide rich, reusable, reliable interactions out of the box. Boa Constrictor already has tasks and questions for every type of WebDriver-based interaction. Each one is battle-hardened and safe. Second, screenplay interactions are composable. Like we saw with searching for a phrase, you can easily combine interactions. This makes code easier to use and reuse, and it avoids lots of duplication. Third, the screenplay pattern makes waiting easy using existing questions and conditions. Waiting is one of the toughest parts of black box automation. Fourth, screenplay calls are readable and understandable. They use a fluent-like syntax that reads more like prose than code. And finally, the screenplay pattern at its core is a design pattern for any type of interaction. In this talk, I showed how to use it for web UI interactions. But the screenplay pattern could also be used for mobile, REST API, and other platforms. Boa Constrictor, in addition to web UI interactions, has REST API interactions as well. You can even make your own interactions too. Overall, the screenplay pattern provides better interactions for better automation. That's the point. It's not just another Selenium WebDriver wrapper. It's not just a new spin on page objects. This screenplay is a great way to exercise any feature behaviors under test. And as we saw before, the screenplay pattern isn't that complicated. Actors use abilities to perform interactions. That's it. The programming behind it just has some nifty dependency injection. If you'd like to start using the screenplay pattern for your test automation, there's a few ways to get started. If you are programming in C#, then you can use Boa Constrictor, the library I showed in the examples. You can download Boa Constrictor as a NuGet package. It works with any .NET test framework, like SpecFlow and NUnit. I recommend taking the hands-on tutorial so you can develop a test automation project yourself with Boa Constrictor. Also, since Boa Constrictor is open source, I'd love for you to contribute. If you're programming in Java or JavaScript, you can use Serenity BDD, a mature, complete test automation framework that includes the screenplay pattern. Serenity BDD greatly influenced Boa Constrictor, but the two are entirely separate projects. Boa Constrictor is not Serenity BDD for .NET. Instead, Boa Constrictor aims to be a simpler, standalone implementation of the screenplay pattern. If you're programming in Python, hold on to your seats. Python is my personal favorite programming language, and I think it's one of the best languages for test automation. I'm currently developing a screenplay implementation in Python in my spare time. It will be similar to Boa Constrictor, but the code will be even simpler because it's Python. If none of those options suit you, then you could create your own. The screenplay pattern does require a bit of boilerplate code, but it's worthwhile in the end. You can always reference code from Boa Constrictor and Serenity BDD because those other projects are open source. If you want to see how to refactor an existing test automation project using Boa Constrictor's screenplay pattern, check out this live stream I recently did with Sabotage Andy, the lead developer of SpecFlow. We refactored all the page objects in an existing project into screenplay calls. The amount of code reduced drastically. Even though Sabotage Andy was new to Boa Constrictor, he was able to figure it out easily. Oh, no, I don't want to. No, stop. Sorry about that. I wasn't trying to play it. You can check that out on your own time. The live stream is about 2 hours long. So thank you so much for taking the time to learn more about the screenplay pattern, Boa Constrictor. Again, my name is Andy Knight, and I'm the Automation Panda. Be sure to read my blog, follow me on Twitter, and reach out to me if you'd like to join the Boa Constrictor project. So thank you. Let's open the floor for some questions.
Awesome. All right. Thanks, Andrew. It's a great presentation. And we do have a question in the question and answer tab asking if Boa Constrictor has API test automation classes ready for use now.
Yes, great question. Unfortunately, for a while, the REST API support was kind of second class, but in the past 2 weeks, my team and I have really dug in. And so we have a new API for testing REST APIs. Underneath the hood, Boa Constrictor uses REST Sharp. So essentially, when you make your REST API calls with Boa Constrictor, you'll be saying things like actor can call REST API using, and you pass in a REST Sharp client. And then when you make calls, you'll say things like actor.calls, that's a new method we added, actor.calls, and then REST, the interaction will be REST.request or REST.download, and then you pop in a REST Sharp REST request object. And then Boa Constrictor will call that. It will automatically log all the stuff to the console. It will also take your request and response, format it into JSON, and then dump it as a log. So that way, after your test runs, if there was something that went wrong, you can dig into the dump directory and go to the request and response that were dumped for that particular call and see, okay, oh, it had a 500, it was unauthorized or something. So yeah, it's pretty slick now. Check it out.
All right, great. Looks like you popped another one in there. Do you anticipate extending the framework to work with desktop applications?
Oh gosh. Me personally, no, simply because I don't test desktop applications. But if someone out in the community wanted to extend it and contribute that code, I'd be more than willing to review it and accept it. Like I said, Screenplay Pattern is not just some WebDriver wrapper. Screenplay Pattern is a pattern for black box test automation interactions, whatever they could be. So yeah, I mean, if somebody wanted to contribute that as open source, I'd be more than happy to welcome it to the project, so long as the code is good. Or if they didn't want to go through the hassle of contributing it as open source, they wanted to keep it proprietary, they can extend it, right? As long as they are familiar with how the interfaces in the pattern work, such as, anytime you want to add an ability, extend I ability. You want a task, I task. You want a question, I question. Everything will simply just go straight through the actor because they're just interfaces. So you can make that on your own if you like.
All right. Great. Okay. Yeah. And Matt just says, thanks for the answers. So I think that's all the questions there. If nobody else has any other questions. All right. All right. Well, again, thank you so much, Andrew. It was a really excellent presentation. I'm sure we all learned a lot from the methods and all your great insights. And thank you everyone to joining us. This is a monthly series that we do. And you can follow our events at dccap.com/events. Again, the hashtag to keep the conversation going online is QA Masterclass. And keep your eyes out for our DCCAP e-sessions. We're releasing a video on December 17th around the holidays. And thank you again, Andrew. It was a real pleasure hosting you today.
Oh, pleasure was mine. Thank you.
Thank you.
Bye-bye.